This is HP Revolve board that was brought in for dead condition. When they brought it, there was two indicators here, and those indicators were blinking even with charger and without charger. So far there is source, whether battery, those indicators were blinking. So at first, when they opened the laptop, I noticed the laptop is not too sharp as per the pins. I mean, somehow there are some corrosions there. Not really corrosion, but the point is I'm not too satisfied with the condition of the board, because all these my components, they are not too sharp. So what I did was first thing by discharging the board. So after discharging the board, the board came out fresh like this. So then the following step is to insert charger and see what is the condition. Now, like we've all known, if I'm to insert charger on my PC, I will check what is the value of my CLR. So, and the next thing is I will reduce this consumption to 1 amp. Although I've already inserted charger and I've confirmed this thing to be short. So now I will just use this avenue to show you how to source for shorts on 19 volt tray. This is my PSU as at 1 amp. Now if I should insert this charger, as you can see, the board is reading short. So the best way I use in finding short is this particular PSU, because this one has calibration. With this one we have different way of sourcing for short on board. I can reduce the voltage and I can keep the voltage the way I want it. Since I'm sourcing for 19 volt, I can keep it at 19 volt. But the main important point is to reduce this amp. This is the total of 5 amp if everything were to supply. But this is what I use in calibrating this. If this is my 5 amp, then if I should put it around there, I'll be getting like half of 5 amp, like 2.5. So if I should put it here, I'll be getting around 1 amp thereabout. So with this, I believe the board will be fine if I should insert my charger. So now what I'll do next is I'll insert the charger here, and as you can see, I have consumption of 0.9. In the first version we've done in other language, we've discovered these components to be short. Where is it? This particular capacitor, although we've checked everywhere, nothing was short, but we discovered this particular one to be short. Actually, it's not getting warm now, but in the first video I detected it with around 1.6, and now it's getting hot. Now I can't even hold my hand there any longer. For double confirmation, I can just put some amount of thinner on this. If you can see it clearly, I don't know in the camera if you can see it clearly, the stuff is burning out fast. So what I'll do now is I'll remove the capacitor first, check if the part is clear, and if it is clear, I'll replace the other one. Then I'll continue with my troubleshooting. So let me quickly do that. In doing that, I use this I don't like getting my table, so I'm trying to keep it off my table. Now I've removed the capacitor. I will check what is the value there. In my multimeter here, I'll place it at diode range and check what is my value. That is the ground part, and this is the other part. If I'm having around 520 something, automatically this part is clear. And as I can see, this is 19 volt real capacitor. So I can test it first, or I should replace the capacitor. But what I will do is I will test it first to know my fate, whether to continue my troubleshooting or my issue is fixed. So in doing that, let me clean the initial flux I placed there. Okay, that part is clear. And I'll use the same DC I've used in injecting voltage. I'll still reduce it to around 1 amp. I'll plug in my charger and I'll see if the board is still shorting. Now I have a kind of blink here and this consumption is down. So with this is just 2 digits DC supply. I will check if there is any digits here at all, because this is not 3 digits. What I will do is I'll use my other DC supply and see if there is any changes at all. Here, as you can see, this board is taking 0.004, which is still the normal range for for the likes of this board. So what I will do now is I will find a way of powering this board, or before I do that, I can just check if there is any standby voltage. What is that? Can you? Okay, now the board has power. The cameraman is showing me that, and it's very dangerous for me if the board has power without heating. First thing I'll check is if this place is heating up, because I saw 500 and something. Immediately I have to turn off the board because it's very dangerous for this. So what I will do next is I will try and put heating on this before even doing anything at all. Don't forget, I'll still replace this capacitor, but at least let me know the condition first. The capacitor are just there as for soldiers, like they are there to protect that section. So even though if they are not there, it will work, but the implication is if there is going to be similar issue another day, there will be nothing there to protect the circuit. So what I'll do, let me place the screen and see if there is any display. This laptop has onboard RAM, so I don't need to bother myself concerning the RAM. So this is Revolve. This is where the power switch is always at. Okay, we are good to go. We are good to go from here. So I'll still repeat the same process. I'll put in my charger. Here I'm no longer testing. I can increase my RAM because I'm sure the rail is fine now. So here, after putting my charger, I'll hit the power button and see if the laptop powers. So nothing is happening on the DC supply, but initially it's power. Okay, so I'll try and use HP charger, HP charger, because at times HP. Let me see if this switch is properly connected. Okay. Yeah, still the same thing. 0.4. Okay, now it has power just like the previous one. Now I have my display. This work, I charge this work for 25,000 and I collect service charge of 2,000 naira. So the board is up and running. Now initially I was doing the Yoruba version of this case study. I will continue from the part where we detected the capacitor, and you know here we've changed the capacitor, so I will still continue from that part in the other video. Thank you for watching.